Welcome to KMIT Vista. In this session, we will be discussing AITA topic of 4th unit, soil management, smart irrigation system and weather forecasting. These are all the three topics which are the applications of AI and ML models. We will be studying about soil management system. So, what is soil management system? So, the soil management system is an integral part of land management to enhance the soil quality for the land used to select. Specific soil management practices are required to protect and conserve the soil resources. So, the main aim of soil management is to protect and conserve the soil resources. Why the soil management is very important? So, managing the soil health allows producers to work with the land not against, to reduce the erosion. Second, maximize the water infiltration. Third one is improving the nutrient cycling, save money on the inputs and ultimately improve the resiliency of their working land. So, what are the objectives of soil management? So, the two objectives of soil management are to reduce all the forms of soil erosion from the agriculture land by soil moisture conservation works. To increase the productivity in the sustained manner without destroying the soil health. The main aim of soil management is always it has to conserve more and more soil health or nutrients, and also to increase or should not deteriorate the soil health. So, if you see here the soil, in this soil there should not be any bugs, there should be more moisture and there should be a more worms, so on. Example is it has to maintain the nitrogen, phosphorus and the potassium in the soil. Next, how to design our AI ML based soil system. So, to design that, first step is to know about the soil health. So, to know about the soil health, normally we use the data collection system. So, to know about the soil, we use soil sensors. So, the soil sensors always collects the information of moisture, temperature, pH and nutrient levels by using the sensors, soil sensors. Next is by using the satellite imagery and drones. The drones and the satellites captures the image for the large scale soil and the crop monitoring. So, next one is we need to collect the weather station data, provide the weather data that affects the soil condition. Next is historical data. Past data of the soil conditions are required and the yields of the crops are required, and what are the management practices they have used, the farmers have been used are very important. The four data is required. One is soil sensor data, second one is images data and weather data, and also the past history of the data that farmer have used into the same soil. Next is after that, once the data is collected and stored in the database or some Excel sheets, the data is pre-processed. We know that once we are doing to build an ML based project, we start doing the data pre-processing. Data cleaning is nothing but removing noise and handling the missing values and the outliers. Next is normalization, always standardize the uniform uniformity in the data, and also feature engineering extracts the important features from the raw data. Next, coming to the after getting the pure data or quality data, we start designing the algorithm. So here selecting or choosing an algorithm is very important. Choosing the appropriate algorithm like regression models or decision tree or neural networks. Next is training the data on the historical data, ensuring the model is generalizing well or not, which is nothing but validation data. Next is we are doing the predictive analysis. Once the data is trained well, we start fitting the model, which is called as predictive analysis. Here we can do three types of predictions on the soil data. One is soil health prediction, predicting the future soil conditions based on the current and historical data. Second, we can create a crop sustainability, recommending the crops best suited to the current soil condition. Next, we can create a fertilization technique, provide the optimized fertilization schedules, etc. Next, support decision support system also we can create, irrigation management system, nutrient management system, soil conservation practices, all that we can do. Once the model is designed, we start creating the monitoring and feedbacking. So once the real-time monitoring is done on the soil conditions using IoT devices, a feedback can be generated to implement the recommendation to refine the or improve the models. So that is what, once the model is designed, we keep on monitoring the model, so which can give a better output. Next, our second model we are going to study is, first model is soil management system, second model is our smart irrigation system. In this smart irrigation, why we need smart irrigation system? A smart irrigation system leverages our advanced technologies to optimize the watering of plants, lawns and agricultures. The system aims to conserve water, reduce the water and ensuring the plant receive appropriate amount of optimal growth. Here we have a tank, pump, driver. Here we have a Raspberry Pi and we have some systems, processing unit and also the database. Once the query is raised in the MySQL from the database gives an query to our Raspberry Pi. So once the query is raised from the Raspberry Pi, it starts processing the data and start displaying the outputs from in the subscriber unit. So once the subscriber have given any processing, almost it senses the water levels and also it Raspberry Pi enables the motors to give a water to a plant, so that it automatically controls either watering the plant or not watering the plant. Activation unit, from that it stops or starts supplying water automatically. Next, coming to here we have a water tank. Here we have a system with a Raspberry Pi. They have defined and it starts giving water to specific nodes. Already you have done this as a simple projects in our second year. So the key components of smart irrigation system are, first one is soil moisture sensors. It measures the moisture content in the soil, helps to determine the precise amount of water needed based on the real-time data. It also senses the weather conditions, including the rain sensors, temperature sensors and humidity sensors, adjusting the water schedules based on the current and forecasted weather conditions to prevent overwatering. Smart controllers, we know that we are using mobile applications and web interfaces to monitor the systems. So next is coming to the connectivity. Systems are often connected to the Wi-Fi or other networks, enable the remote monitoring and controlling through the smart phones or tablets or the computers. So one is smart irrigation system, second one is soil management system, the third one is our weather forecasting system. So building an AI model for weather forecasting involves the steps including the data collection, pre-processing, model selection, model training, evaluation and the deployment. So here what type of data is needed, where we need to collect the data. So the data can be collected from various sources like APIs, public APIs like Open Weather Map or Weather API, governmental and institutional databases, NOAA or NASA. Next one is historical weather dataset like metadata, etc. From there we can collect the weather data. Based on weather data we start creating our data pre-processing. Once the data pre-processing is done, here cleaning the data, normalizing the data, feature engineering is the same old concept, but here we have one for weather forecasting, we have one more special data pre-processing called as temporal pre-processing. So temporal pre-processing converts the timestamps into the useful time features like hours, day of a week, etc. So this is the special feature that we use in weather forecasting. Temporal processing, it converts timestamps into the useful time features. Next is model selections. Weather forecasting can be done in different ways. One is called as statistical method. Several types of models are used. One is called as statistical models. With the statistical models, we can create our own API live update system, which is a weather forecasting system. There we use ARMIA and SARMIA. ARMA is auto regressive integrated moving average, and SARMIA means seasonal auto regressive integrated moving average. With this we always create our temporal processing. Next is machine learning models. There we can use random forest or gradient descent. For deep learning models we use RNN, LSTM, GRU and CNN. And also we can use mostly the LSTM because it is more effective for time series forecasting. Next is we start LSTM training the data. Once the training is done, we are trying to fit the data. Once the fitting is done, we try to evaluate the model. Once the evaluated model is there, we try to deploy in our HTML code with the Flask. So, and develop the web application. Thank you.